All right, good morning. How are you guys doing?
Doing well. How are you?
Excellent. Well, all right, people are slowly adding into the call. I guess I'll give it a few seconds, but any questions out there? Trouble, difficulties, tech issues, or otherwise? The keynotes, the keynote live is going on chapter 12 where we left off last time. If you want to have that up, uh, my goal today would be to work through the end of chapter 12 and then start chapter 13 so that we could start watching for collisions, which will allow us to have sound effects and stuff, which is a big next step. We were here. We finished here using runtime to listen for taps. So the idea was you can create an app with a runtime object, but we're going to drop a magic ball. So just really quickly, I'll work through this. And
Should we be seeing your screen?
yes, do you not? Let me start again. Thank you so much. So if it shows up, what you should see is drawn a code and a gigantic magic ball in the middle of the design. All I did was add an image. Anybody seeing it?
Yes, thank you.
Excellent.
Yes,
Thank you so
Jenna.
much. Perfect. Just gonna resize the ball a little bit. So what we did last time was we added a runtime, which is at the bottom of the physics menu. We added a listener, which was the tap listener. Once I start screen sharing, everything goes so slow. So that gives us now a way to detect if the user's tapped the screen anywhere. We didn't add it to a specific widget or a specific shape. We just added it to the whole app, which is the whole screen. And then we can drop a magic ball using physics when the tap occurs by moving the ball into the tap handler. So I'm going to do that by hitting move image into function. There's only one function. And then I'm going to, I'll set up physics so that I'm able to add bodies correctly. And then I'll add the magic ball as a physics body by hitting add body. And since I'd already moved, let me get this stack a little bit bigger so you guys can see it, I hope. Since I already had the image inside the tap handling function, the add body automatically went right where we want it. So this is what we ended up with last time, which was an app that will wait for you to tap. Actually, this is going to work, but you're not going to see anything. I just realized, but might as well do it so you can see what happens when you do something wrong. So it is listening for the tap. You can see it's telling me where I tapped, and it should be based on that creating and dropping a magic ball. And of course, it is creating and dropping a magic ball, right? But I put the magic ball over here, so it's doing it off screen. So I'm going to move it just up here and save it. Let's see, ball drop one.
I'm sorry.
Yeah.
How do you have a tap function or a tap handler on like the whole app, like on the whole screen, and not just on an object?
Right. So you have to add a runtime object, which is at the bottom of the physics menu.
Okay.
And once you get that, then just add the listener to it and pick the tap listener.
Thank you.
Oh, you're welcome. You're welcome. This should work now. There we go. So if you tap, you should get a ball drop that you can now see, which is better. That's most people think that's better. Yeah, I was working on an app to an example for you guys later in the semester yesterday, and I kept adding this wall that was slightly off screen, but I wanted the ball to hit it. And I left it as a dynamic body, so every time I started the app, the wall dropped, but it was off screen, so I didn't see it dropping. That was stupid. Okay, so this is what we ended up with last time, and I said the next step is to modify this so that the ball is dropped from where the user taps. And I challenged you guys to think about that and work on it. Um, did anybody try to get it working and not? It's not super tough, but it's like one of these things. Once you see it, then it seems super easy. But before you've worked through it, it might not seem super easy. So if we want to modify this so that the ball is dropped where the user taps, the thing is we already have that information, right? It's part of the tap handler. It's part of the tap event, I should say, that gets to the tap handler, and we can ask it where the user tapped. It's using that event.x, event.y syntax. The same syntax we use to form the basis of dragging stuff. It just identifies where the user's finger touched the screen. So to work with that, to improve this, to do that, we'll need to be in the tap handler, in the OnTap, function, and we're gonna have to rearrange this slightly. So we want the image to be created first. So I'm gonna move it up. So now I've got in the OnTap function, I've got the image, then a snippet, then the add body. And I'm gonna work in this snippet, which for me is object 4. And I'll pop this out and zoom in. So you can see the syntax is already here in the default code that I write for you in Drawn to Code. So all we want to do is we want to locate the image, or rather relocate the image to where the user tapped. Otherwise, the syntax we want is object1.x equals event.x and object1.y equals event.y. Object 1 is the image we're dropping. So if you're following along, you should be able to now tap wherever you want to and get a ball to drop from there. Next step on the keynote is perform tasks using inner frame. All right, so the idea of inner frame is that it's another listener we can attach to the runtime, and it will automatically call a function 30 times per second. So essentially it's running at the frame rate of a game if the game is running at 30 frames per second. So it gives us a place to put code that runs as soon as the app starts and keeps running potentially until the app ends, to allow us to do stuff just over and over and over again. What we're going to use it for is animating stuff on screen like a moving platform. So let's just start out with a really simple version that doesn't do much. So I'm closing this design that I was working on to get me back to the empty stack. I'm going to add the runtime, and then I'm going to add a listener. And this time I do want inner frame. And if we look at the stack now, you'll see it's a little more complex than usual. There's a snippet, object 2, that was created. Object 3 is the event handler function. Object 4 is the default snippet inside of the event handling function, and then object 1 is our runtime. So there's more going on, a little bit more going on here than in some of our previous examples. So let's just peek at it. The snippet above is just 2 comments. One really long comment and then one short one. So it says optional to run code periodically, uncomment next line to use. So essentially it's saying this code on line 14, which is commented out, could be commented back in and then used inside of the default snippet inside of the inner frame event handler. So just remember that when I show you code inside of the event handler that uses this variable last time, to actually use it, you would need to uncomment this line 14 to make use of it. Otherwise, the variable last time won't exist when you try to use it. All right, so let's look at this default snippet. Let me zoom in. Okay, so first off, this is the only snippet, the only default snippet you've seen in Drawn to Code so far that actually doesn't do anything. It's all, if you look at it, it's all commented out. So there's a couple reasons. One is, normally what do? Normally I do a print statement that uses some of the event syntax to report data out to the console as events occur, right? So in the tap handler, every time you tap, I put out this, this information to the console. There we go. About where the user taps. But I haven't done that here. The reason I haven't done that here is because this function gets called 30 times a second. So if I do a print statement in here that says, hey, the event handler was just, executed, I'm going to get 30 lines of data to the console every second, which will fill up your console, and it's too quick. It's too quick even to read or to make sense of, obviously. So this is all commented out. So by default, this function, and in return this snippet, this default snippet runs 30 times a second. Sometimes that's what we want. We're going to use it to move a platform back and forth using the 30 frames per second speed. But if you wanted to see something at the console that confirmed to you that the inner frame was actually working, then we could comment this code out. So that's, as a first step, that's what I want to do. The thing that sometimes confuses people is you're not paying attention is that some of these need to be commented out, but some of them are comments, which you don't want to comment out. So if that makes sense, I mean, looking at lines 20, 21, 23, those are all just comments. 24 is an if statement, so I'm going to comment that back in. Essentially, all of this needs to be commented back in. Although I still have people sometimes putting this do something every second comment in the code. That doesn't work. That's why I was double commented. The print statement will work, and then the last time update will work, and then the end statement. So if you're following along, all I did was I removed the commenting from these lines, leaving line 25 though as a comment. This won't work though because I didn't uncomment last time, right? So if I head back to the stack, look at this snippet on object 2, find it, here it is. I want to comment in last time. All right, so just to think about what this is going to do a little bit, this app will start and then hook up a 30 frames per second event handler, and then 30 times a second, this code will execute. All this code does is say, has it been a second since the last time the code inside this if statement was executed? If so, execute it again. So by looking for the difference between the current time, which is event.time, and the last time that this was run, which was our variable that held event.time the last time it was run, if that gap is greater than 1,000 or 1 second, 1,000 milliseconds, then we're going to print this at the console that just says it's been a second. If you weren't able to wait and you've already done this, what you'll see is nothing on screen. Let's see, we'll call this inner frame 1. You'll see nothing on screen, but down at the console, you'll see every second it says it's been a second. It's been a second. And again, if we were to, if you were to display event.time at the console 2, this is running roughly every 1,000 milliseconds, but as you guys have seen in the past, it's not necessarily exactly 1,000 milliseconds. But this will keep running also forever. There's nothing in this code that would stop it. The interframe is started, the handler's executed 30 times a second, and then once every second it runs this code that's inside of the if statement. So the idea of this system is that if you have something you want to run uh, uh, as the app executes, but you don't want it to run 30 times a second, you want some other speed, you can use an approach like this to say, do something every second. Or if you wanted to do something every 2 seconds, you'd change it to 2,000. If you wanted it to be every 5 seconds, you change it to 5,000 and so on. And you can have multiple of these if statements. The code I was working on yesterday, I actually have two. I have something that's going maybe every 2 seconds, and then something else going every 4 seconds. In addition to a moving platform, which was going at 30 frames per second. So you can put a lot of code into this interframe handler. The one caveat or another caveat would be, since you're doing things at up to 30 frames per second, you don't want to do anything that takes a lot of time in here. You don't want to load an image in here because there's no way it can keep up with the frame rate. You'd want to load it, say, before this executed. Stuff like that. Yeah, let me pause. Any questions?
Yeah, why don't we use a timer for this?
So you could. You absolutely could, but you already have, essentially, once the physics engine starts running, you already have this kind of timer going, and we're just tapping into it. But in general, the advice would be, if you want to move something that's an object, a physics body in the physics engine that is currently being simulated, then the runtime is probably the way to go. The moving platform will be our first example of using this really. If you want to code this along, you could keep coding the app that we're in, certainly, or start over. I think I'm just going to keep coding, so I'm going to make a platform. If you don't have the keynote up, let me just show you two. We're here. So we're going to create a little moving platform that bounces horizontally back and forth across the screen, and then we'll also add a magic ball that we can drop and watch it hit or miss the platform. So I need two things to really get this working. I need a magic ball, so that's an image. We are there's the black and white one. You can use the color one, whatever you want. You can resize it. Whatever you want. And then I need the rectangle for the platform. So it is something shaped maybe more like this. I made it red in the outline, which you can do or not. Obviously, in the keynote, I also have a fancy sky background, which is just a gradient. So let's add that really quick because I did want to show you something I added. So when we do the background gradients, we normally start with a rectangle and then make it slightly wider than the screen to handle different aspect ratios, and then also slightly taller than the screen to handle different screen heights. But then when we do this, you end up with this big image. I haven't added the gradient yet, but we end up with this big image that's in front of everything, and we don't want it to be. So we'll send it to the back by moving it up the stack so that it's drawn first. But then sometimes as you're trying to say grab the platform or grab the magic ball, you accidentally slightly miss and grab the background instead of the platform, which is annoying. So I told you in the email I added this lock feature. So if you downloaded the very latest version of Drawn to Code, you'll have lock this object in place. Once you do that, you won't be able to move it if you try. And the sliders are also disabled where they're at. And then in the stack, you'll see there's a little extra symbol. Kind of looks like a safe with the door shut. Anyway, it's as close as I get to a lock symbol. There is no great default Unicode lock character. So that was as close as I could get. Anyway, as you lock it and unlock it, that'll show or disappear. And it just keeps you from accidentally dragging something away from or when you were intending to drag something else. White looks terrible, so we really do need a gradient of some sort. I'm just adding some sky-ish colors, and then I'm going to set the gradient on the rectangle. And you don't need to do that if you're trying to follow along. You don't need to do that unless you want to play around with the lock, the new lock feature. Okay, so this would run, but it's not going to do anything exciting. All right, where's my... Oh, okay, so yeah, this is not working. Totally my fault, but let me pause and pretend that I did this on purpose. Why are you not seeing the background, the sky background? Anybody? I'm not hiding an error over here, but I have done something wrong. All right, it's such an easy mistake to make, and I wish that there was an error at the console. But if we look at the stack, what you'll see is, here's that rectangle, that background rectangle, and I set the fill color to be the gradient, but the gradient's down here, which means that when object 7 was initialized, the gradient was nil, so the fill color is nil, so you don't see it. So to fix it, I just need to move the gradient up so that it executes, top to bottom, so that it executes prior to creating the rectangle and filling it with the gradient. So no syntax error, just a sequence issue, an out of order sequence issue. All right, it's still not super exciting, is it? The platform is just sitting there, so how do we move it? Let me see. I mean, if you're ahead, or this is all making great sense, you can get ahead. We'll need to start the physics engine and add the ball and stuff in a minute, but for the time being, let's just do the platform because that's what's maybe the most fun. So in the keynote, you can see I've got handling the move, the slide. The basic idea of doing one of these moving platforms is that you want to know where it starts and where it ends and how it gets from one to the other. This is just a platform that's going to bounce horizontally left and right. When it hits the left edge of the screen, it'll reverse direction towards the right, and when it hits the right edge of the screen, it'll reverse direction back towards the left, and it'll just keep doing that forever. So that's something we want to do as the game is running, kind of in real time. So we'll do that inside of the inner frame, on inner frame function that's running at 30 frames per second. So I'm going back into the snippet we've already been in. This is where we did this code that did something every second. So you can leave that there. You could comment it out. You could do whatever you wanted. I'm just going to leave it there because it doesn't hurt anything. Although in a large, complex app, you want to be really careful with every single thing you do inside of the inner frame. In this case, it's not going to get that complex. So first off, how do you move the horizontal position of that red platform? Well, you change its X value. The platform is, let me give it a name so that it shows up better in the stack. I call it the red platform. Okay, so now glancing at the stack, it's more obvious what it is. So inside of this snippet, we want to edit the object6 x value in some manner. So, I mean, to make it move to the right, we'll do object6.x equals object6.x plus some value, some number of pixels. This will be a number of pixels that it moves 30 times per second. And you'll just get a sense of, I mean, for most things, a speed of 2 or 3 is probably right. That'll move decently quickly, although you can also make things move or rotate or whatever at different speeds, or you can change the speed as it runs to make it more complex. But just starting off really simple. All I've got it doing is adding 3 to the x position of object 6. This is not the complete way to get it to work. It's just a start so that you can see what happens. So if you missed it, it just kind of slides off to the right all on its own, and it keeps going. Right? It's actually still going. It's about out of my office, I guess, by now. So that's part of what we need. Obviously, to move it to the left, we'll say object6 object6.x equals object6.x minus 3. My gosh. But we need to, I mean, those are the two main things that we're doing, but we need to know when do we move it to the right and then when do we move it to the left. And there's different ways to write this, but the main thing we want to do is we want to detect, has the platform hit the rightmost location where we want it to go? If so, then we need to reverse direction. Or has the platform hit the leftmost location that we want it to hit, in which case we also switch the direction in the other direction. So I've got an example of this code inside of the keynote, which you could cut and paste, but in the keynote, my platform's object 1, and here it's object 6. You'd have to adapt it a little bit. So I'm not going to copy and paste it. I'm just going to get in here and type. So I need an if-else-if statement. I need some condition. I'm going to come back and write it. I'm just going to start with the basic syntax. So it's if condition then, and then else if another condition then, and an end. Just trying to make it as readable as I can. So I need those conditions now. So I wanted to move to the right when the platform hits the left edge of the screen. Yeah, there's different ways to write this, but if I want to switch it to go to the right when it hits the left edge. So it hits the left edge when object6.x. We can start by just saying is less than 0. The other condition really basically is just the opposite. It's object6. Oh, come on. Object6.x is greater than 320. So this isn't going to work as it is in the keynote. Is I've created a variable. I called it platform speed, just because it's going to take the place of the 3 and allow me to kind of condense the code a little bit. You don't have to use a variable. You could use hard-coded numbers. The idea of using the variable would be when you decide it's a little bit too slow or a little bit too fast, you can just change the value in the variable rather than hunting through your if-else-if statements to tweak any pixel values. Same platform speed equals 3. And what I'm going to do is move the movement line outside of the if statement, and I'm going to recode it so it says object6.x plus platform speed. I'm going to get rid of this one. Try to get rid of this one. There we go. And all I'm going to do in these these edge conditions is I'm going to reverse direction. So I'm going to do that by saying platform speed equals minus platform speed. I mistyped that. Minus platform speed. So what does this mean? It means that I'm moving at 3 pixels per event frame, so 30 times a second. So I'll move 90 pixels a second basically. So it would take me roughly 3 seconds to get across the screen at this speed. And when I hit the left edge, it's like a left bumper. I'm going to reverse direction. When I hit the right edge, it's like another bumper, and I'm going to reverse direction as well. Oh, sorry. Let me pull this out. Yeah, that shouldn't be in there because I'm setting it equal to a positive value there, resetting it to a positive value every time. So I want that line of code in a snippet that's outside of the runtime. I already have a snippet here. So I could get in here. This is where the last time value is. Okay, and I'm just gonna paste platform speed there. Let's save it while I. Oh. So if you're trying to follow along, let me try to get both these snippets on screen at once. That's not it. There we go. Okay, so you can almost see everything all at once on screen, I hope. The moving platform, all it's doing is it's moving 3 pixels per second, either in the right or the left direction. It always moves 3 pixels, at 30 frames per second, 90 pixels per second. So what are the rules that make it change direction? That's the if statement here inside of the inner frame event handler. And this is a little bit simpler. That's in the keynote, and I'll explain the difference between this and the keynote in just a second. But just big picture, all it's doing is saying when the platform, the x value of the platform hits 0, reverse the direction, and when it hits 320, or is slightly greater than 320, so 321 or less than 0, -1, reverse direction. That's all it's doing. These are 2 rules that cause it to reverse direction. And then it uses that direction down here to do the actual incrementing of the x value platform. So what's missing now is we don't have the ball. We don't have any physics, right? All we have is a moving platform. So how do we take the next step and get ourselves a physics app with a moving platform? So let's do that. It's not a physics app. I don't have physics running. So I want to head over to the physics menu and start physics. You hit it by hitting the setup physics button up at the top. That will add the setup physics to my stack, which gives me control over gravity and the physics mode. And then I want to drop a ball when the user taps the screen. So I would probably use the runtime for that. Although in this case we do have this gigantic rectangle in the background. If you really wanted to, you could hook the tap listener up to the rectangle. That would work as well. But now I have a runtime. I'm going to add the tap listener to the runtime. Which gives me, just rearranging the stack slightly. Okay. Oh, come on. Okay, so there's inner frame, which is already there. Here's on tap. So when the user taps on the screen, I want to drop a magic ball. So I want to move the magic ball into the function. And I want the on tap function. And then I want to add the magic ball as a physics body. So it is selected, and I'm going to hit add body. That is what I want, and I want it to be a default dynamic body. I want it to drop under the force of gravity. So we're not quite there. We've got half of it. So we have got the ball, it will drop. We have a moving platform, but the moving platform is not a physics body. So last step is we want to select the moving platform, add it as a physics body, and it is generally best to make this a kinematic body, which means it's not going to fall under the force of gravity, but we can move it and use collisions with it. This could go at the very bottom. For whatever reason, I always want my runtime at the very bottom to make it easy to find. So I'm going to move this up. The only limitation is, in terms of stack order, is that it needs to be below the rectangle that's being added as a physics body. So object 6 is what we're adding, so object 13 has to be after wherever object 6 is in the stack. I think that's a good order. Let's save it and see. Should be able to tap the screen and get I missed. There we go. Okay, so right off the bat, that's not working right. If you're watching, you'll notice that the ball, kind of goes through. So what's going on, again, just to work through it, is let's look at the hybrid draw mode, switch it to hybrid draw mode in physics setup and save it. What's going on is the physics shape for the magic ball is bad. And you can see it, it's half of a ball. Not working right at all. So that means that the shape of the magic ball is bad. So to edit that, we go to the add body statement for the magic ball. And I'm going to change it not to use the image outline, but instead to use a circle. And I hit refresh to get an up-to-date radius for the circle. I've left hybrid draw mode on, so we should see now when we drop the ball that, hey, now it's actually a round physics body. So I'm moving ahead in the keynote, and this next page is really just a demo. It's just a hey, look at all the stuff that you can. It just is movements. Ooh, well, that's not good. Corona just crashed. I hate clicking OK there. It's not really OK. Something less than OK. Whoa, all right. Let's try this again. I'm not sure what. I will play around with it, and in the video when I upload it, I'll tell you how I got it working, but it's not giving me, it's tough because it's not giving me an error. An error that tells me what it doesn't like. But if it's running for you, it is a cool little app. The stars, rotate, the gear wheel rotates, the magic ball rotates in the other direction inside of it, and the platform on the left-hand side goes up to the top of the screen and then back down and then up, back up, and then back down. So it's one I don't know if cohesive is the right word, but it's one example that has all these different types of movements in it that you always refer back to if you're thinking I want to make a game and I want something that does something like this. Movement or movements is the design which has a lot of that going on. All right, let me just see if this version will run. But here's what this is what movements is supposed to look like. And so it should be in the download, but again, there's something wrong with it. But it should be in the movements folder in the chapter 12 folder that's in the download for the book. There's one last thing, which is an activity, which is kind of fun. So I thought normally what I do in class is I would give you guys 15 minutes and say, hey, try to solve this. I'm just going to start it directly to make it quick, but I'm going to try to start it. I'm not having the best luck today. I just ran this yesterday. Move the ball activity. Ooh. It does not like the design, and it doesn't want to. So something I did last night in this update is causing some issues because this ran great last night, but I guess I was using the older version of Drawn to Code, so I will hunt down what is going wrong, why it's going wrong. If it runs for you, it's a fun little one to play with. The idea is that you've got a timer that's running and counting down, and you need to get the magic ball. Let me get it on screen just so you can see the design. You want to get the magic ball from the starting place through the exit door over here, and you do it by creating moving platforms, which is the previous example. So you need a platform that raises the ball up and then shoves it to the right, but doesn't let it fall into the gap between the lock boxes, and then does let it drop here and be deflected through the exit over there. And teams solve this in wildly different ways. It's always kind of fun to see, but if you want to play around with it and it's loading for you fine now, go ahead and do that today or before Thursday. So if there are any questions, you can ask me. That is then the end of chapter 12. With an asterisk that we have some technical difficulties that I'll update you on for these last two examples. But big picture, you now know how to create a 2D world or a 2.5D world that controls motion, gravity, mass, friction, balance, density. You have control over all of that, fairly easy control over all of it. You've also learned how to use the runtime object, how to listen for taps or any event anywhere on the screen. You've also learned about the inner frame listener, which is new, that runs at 30 frames per second and allows you to do stuff really smoothly, continuously throughout the running of the app. So chapter 13 is the second URL I sent you. It's just starting now. I can't play two of them at the same time, so I quit the chapter 12 Keynote Live. So if you're watching it, I guess it should have stopped, and then it's starting up chapter 13 for the first time, so there's a bit of a delay, but you should see Physics 2 Collisions, chapter 13, within a few seconds on your screen. Assuming you guys do see that. Chapter 13 is, if you don't have it, I'll move along here too, but all about collisions. So we've got all this physics working, we've got stuff colliding. So it's a little bit confusing when I say, hey, this is all about collisions, because there's a tendency to think, well, we're already doing collisions. The magic ball has been colliding with ramps and colliding with our moving platform, and all this stuff. We already know collisions. What else is there to know about collisions? So really the topic of chapter 13 is about how to respond to collisions, how to listen for and respond when collisions occur to do something that we want to do. And probably the most obvious example would be to play a sound. So far our physics games are completely silent, which is kind of weird. If you see a ball hitting something, you would expect some sort of a sound to occur, to happen, but it's not happening because we need to tap into the physics engine and listen for collisions and figure out if it's a collision that we want to do something about. Like it's the magic ball hitting the ground, and maybe we want to play a sound when the magic ball hits the ground. So let's just do a really quick example of that. I know I'm just about out of time for you guys, but I'm going to do a quick example with the magic ball. If you want to follow along, you can. This is actually pretty quick. I'm going to say image, get into today's class, some version of the magic ball. I also need a rectangle for the ground. So I'm going to add that, widen it up. If you're quicker than me, you can change it to dirt or grass or something else. I've got physics started, but I need to add bodies. So I'm going to add the magic ball and leave it as a dynamic body. I'll make the bounce bigger just because we know it's not very good. And then the rectangle, the ground, I'm going to add it as a body. But obviously with the ground, I'm going to change it to static. And then I need a sound. I'm going to add to the magic ball, I'm going to add a listener. I'm going to select the collision listener. So if you're trying to follow along, all I did was hit the add listener button on the magic ball. Like this now gives me the collision handler and a snippet in there. If we save it and run it, say collision 1, if we save it and run it, we should, there we go. Oh, so the shape of the, yeah, I keep doing this. The shape of the physics body's bad. So the image, the add body for the image, I want to use circle, and then the sound. So if I want to load a sound, that's an action. So I want to load the sound, and there are a couple sounds I give you, but low bump I think is in this chapter. So I want low bump to sound when the collision occurs with the ball. So I want to move that into the collision handler. So I'm going to move the resource into that function and then save it. Give us a bouncing ball with a bump sound every time it hits the ground. Oh, I didn't play the sound. So sorry, really stupid. Load sound, I don't want that in the function. I want the play sound, which I forgot to add. That's the one I want in the function. So I missed one script object. What I want to do every time it collides is I want to play a sound, not load a sound. I just did it wrong. Trying to hurry. So
Sound before the play sound.
You can. There's your sound, but so yeah, I've got the play sound above the load sound in the stack, but that's fine because that sound won't get played until after all of this has been executed.
Okay.
Because the ball won't even start to drop until this is called. So by the time it gets to there, load sound's already been loaded. But if it bugs you, and sometimes this stuff really bugs me, I mean, I'm trying not to pass on all those little programming quirks that annoy me, but I do normally load stuff very early in the program. I would load all my sounds, load all my images. Also because then I can look in the stack, and I know if I want to look for an image, hey, I need to look up towards the top of the stack. All right, I'm out of time, and that will pick up on Thursday with chapter 13, collisions, and figure out how to get different sound effects to play and how to take other actions when collisions occur. You know, more fun stuff, and it will enable stuff that's even more game-like and hopefully more fun and interesting to you guys.